So to describe this more concretely, if we look at the sine functions, sine of x or cosine of x, these two functions have very special property, which is that if you shift the argument by 2 pi, which of course 2 pi is like 360 degrees. If you shift the argument by 2 pi, you get back the same value. A cosine and sine are functions which we call in mathematics periodic functions. So, but if we look at it from the point of view of symmetries, what it means is the following, that at the outset, say, cosine or sine function is defined on a line, right? So for every value, every real number, we can evaluate the sine function or cosine function. It's a function on the real line. But on the real line, we have translations. We can translate an element, each point of the real line, by 2 pi, or 4 pi, or 6 pi, or negative 2 pi. So there is this group of translations by multiples, by integer multiples of 2 pi, and the function itself, the sine and cosine function, is what we call invariant under such translations. In other words, if you apply that translation, the function will not change. That's just saying that it's periodic. So that is the framework for harmonic analysis in mathematics. That is to say that we have a space, which in the case of sine and cosine functions would be just a real line, and we have a group of symmetries which acts on it, which in this case would be just translations, just shifts by 2 pi, 4 pi, and so on. Okay? And then you look at functions which are invariant under such translations, which would be sine function, cosine, and etc. So, but there are other contexts where something like this could be done. And the one important context is where the real line is replaced by a unit disk. So you have a unit disk, and you can think of it, it's actually useful to think of it as a disk embedded into what we call the complex plane. So you think of the points of that disk as complex numbers, and there is a remarkable group of symmetries which acts on that disk, just the way the translations act on the line. And then we can look at functions on that disk which are invariant under such transformations, under such symmetries. Those would be the analogs of the sine and cosine functions, and they are called modular forms.